Hello students, welcome back. Proportional relationships lesson 10. Here we will learn how to work with proportional relationships that involve average speed and constant speed in order to write linear equations of two variables. I know you don't know what the two variable equations are. We're going to work on that in a second. We will use linear equations in two variables to answer questions about distance and time. And distance and time problems are very common, especially in math and especially in physics. All right, so average speed is found by taking the distance traveled in a time interval divided by that time interval. So for example, if y is your total distance and x is your time, then y divided by x is the average speed. And you may recognize this from last year or the year before when finding constants in a proportion. So the average speed over a time interval, then we have a constant speed, which you can use to express in the linear equation of two variables relating distance and time. So y divided by x equals a c, and c is our constant. So a constant is a number, right? And y divided by x are our two variables. That's what we mean when we're talking about a equation in two variables. Y over x can change, but they're always changing at a constant rate, right? So you may recognize that as our standard proportional relationship, y equals kx, because y divided by x equals k. We're also going to sometimes call it distance equals rate times time, okay? You'll see more about that in a little bit. Let's take a look at our first example. Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? So if the distance equals the rate times time, distance is 2, time is 25. Let's fill out the whole table and see what it looks like. So we go up every 2 miles is a 25 minutes. So these are going up by 2s, these are going up by 25s. How can I figure out the 137.5? Well, I can't with this table because if I keep going up by 25, I'm never going to get 137.5. But I do know y divided by x is always the same. So y divided by x is always the same number. That's going to be a straight line. So every 2 miles he's walking the same amount. I can figure out y equals k times x to figure out the 137.5. Okay? So take this table. Here's how we do it. Take this table, flip it on its side if you like. So every one of these is a equivalent fraction. 25 over 2 is equivalent to 50 over 4 is equivalent to 6 over 75 over 6, etc. So if I go here and say, well, if I have a equation all the way at the end here where I have 137.5 and I don't know that, so that's x over 137.5. That's equivalent to 25 over 2 is equivalent to 137.5 over x multiplied by the denominators on both sides so it stays equal. The 2's cancel out on the left and the x's cancel out on the right. So I have 25 times x equals 137.5 times 2. So that's 25 times x equals 275 times 2. Divide both sides by x and by 25, and I have x equals 11. So it would take the distance he would travel in 137.5 miles. So if he walked for 137.5 minutes, the distance he would travel would be 11 miles. Okay. Because the answer to this question is, we have to write the answer saying, Paul walked 11 miles in 137 minutes. So Paul walked 11 miles in 137.5 minutes. Neatness doesn't count. So we set up on our equation, we solved our equation, and we wrote our answer for full points. Okay. Now we can move on to the next problem, which says, for any proportional table, we can find a unit rate. So if y is miles and x is the hours, then any miles divided by hours equals y divided by x. So the constant of this would be 41 miles. So the distance equals 41 times the time. Distance equals y equals 41 times the number of hours traveled, or the distance equals rate times time. So on this one, you may see a lot in the coming years, distance equals rate times time, distance, time. So distance divided by time equals your rate. Always remember that, because you will often say, give this equation, but you'll have to say, well, distance divided by time equals my rate. Or you can say distance divided by the rate equals your time. Okay, so when you're given these rate problems, you'll be given two of the variables and you'll have to figure out the third variable. But the two variables can change, because anytime you walk for a different amount of time, you get a different distance. That's why they say variables in two variable equations. Okay. All right. So let's take a look at this one. Alexa walked from the Grand Central Station to 42nd Street to Penn Station on 7th Avenue. This is New York stuff. The total distance traveled was 1.1 miles. It took Alexa 25 minutes to make the walk. How many miles did she walk in the first 10 minutes? Well, if this was an average, then we can say she walked 0.44 miles, because 1.11 divided by distance equals rate times time. So 1.1 divided by 25 is 0.44. So if she walked at a constant rate, she walked straight there, she walked a little bit less than a half a mile. So if it took her 25 minutes to walk 1.1 miles, the rate is 0.44 miles per minute. So in 10 minutes, she would walk 0.44 miles. But what if she walked 0.3 miles in the first 8 minutes and then stopped at an ATM for 2 minutes? Was her rate of speed faster or slower? So she's no longer constant, right? She walked at a constant and then she stopped. So her rate of speed would actually be faster, because now it was 0.3 divided by 8 and then sit and wait. Okay, so she reached the 7th Avenue junction in 13 minutes, a distance of 0.6 miles. She met a friend and talked for 2 minutes, so now she has another stop. No, she was not walking at a constant rate. Sometimes she stopped, sometimes she walked, sometimes it was faster, sometimes it was slower. Okay, so with this table, we can see we were wrong when she walked 0.44 miles in 10 minutes, because she only walked 0.3 miles. So in the 10 minutes, she walked 0.3 miles. The first 8 minutes she was walking, the last 2 minutes she was standing still, and then she was walking, and then she was standing still, and then she was walking. So it's not a constant rate for her. Okay? And we can prove that by saying if we divide y divided by x in all of these, we get a different number for all of these. Okay? Lesson 10, here's your practice. The problems will be at the end. And then we learned work with proportional relationships, average speed and constant speed, in order to write a linear equation with two variables. Remember, they have y divided by x. Those are our two variables. Gets your constant speed. And then we use linear equations in two variables to answer questions about distance and time. So the average speed we find by taking the total distance traveled in a given time and divide that by the time interval. So if y is a distance and x is the time, y divided by x is your constant, is your average speed, and that's a constant c.